Hi guys, you are welcome once again to the Smart Way lectures on the Science Ambassador series. We are here to continue on chemistry and on the topic organic chemistry. In our last video, we elucidated the structure of organic compound and we talked about the elemental determination or elemental identification. This time around, we are going to move on to now use the identification of this element to now ask or estimate how much of this element that we have obtained. In our previous video, we started with the sample preparation and then the separation and the purification. Now we have talked about the identification. Now it is not enough. We have to now find how much of the various elements are within the sample. Remember the sample we took, that is alcohol. We are targeting alcohol and the hair, or we can take the natural the CH what compounds. Okay, very simple. The CH compound, that is the hydrocarbons. And so we have done that. We are now going to now examine how much of the elements are within the sample. So what do we do? Percentage determination. This is also called quantitative determination or quantitative analysis. This is the test that is run. The percentage determination is a test that is run to identify how much of the various elements are within organic sample by striking or finding the various percentages of the various elements that are within the organic sample. Now, assuming that our sample is our pure hair, the normal hair on our head that we have taken, or the alcohol, the hydrocarbon, that is the carbon and hydrogen containing compounds. Now, assuming that that is what we have estimated, that is what we have identified, carbon and hydrogen, we have identified that. Now, how do we find that? Very simple. In that procedure, it is the same. So what we will do is that whatever we did in the qualitative determination or the elemental determination or identification, we are going to do same, but we add a little bit on it, and then we now find how much of the elements are there. So in the procedure, what basically happens is that the sample, a known mass of the sample, okay, so a known mass of the sample, so a known mass of the organic sample. So the known mass of the organic sample, this time we are not just going to take any quantity of the hair organic sample. We are not going to take any quantity of the pure alcohol. We are going to take a specific mass of the sample. So let's say we took, say, maybe give me a number, say W grams. Okay, let's say we took W grams of the sample. Okay, let me use a different color here. So let's assume that we took W grams, that is W grams of the sample. Now a known mass of the sample is taken. That means that before you use the sample of the hair or maybe the sample of the pure alcohol, you have to weigh the mass. Because various quantity of organic substance contain various amount of hydrogen and carbon, and so before you begin your sample, you have to first determine how much of the sample are you going to examine the hydrogen and the carbon in it. So a known mass of the organic sample is combusted or oxidized. Okay, so it's combusted or oxidized. Okay, so let's say combusted or oxidized in excess oxygen, or otherwise using the word with what? With an oxidizing agent. So in the equation, this is the sample, a known mass of the sample, or the organic sample, is oxidized with excess oxygen, okay, and that leads to the conversion. So we know that basically its constituents are carbon and what? Hydrogen. Its constituents are carbon and hydrogen. So once you burn it in excess oxygen, or you combust it with excess oxygen, you are going to convert all the carbon into carbon dioxide, and you are also going to convert all the what? Hydrogen into what? Into water. So basically that is what we are going to do. We are going to do that. So you convert all the mass, okay, inside. We are going to convert everything, okay. You are going to convert everything. Very, very simple thing to get. So once you do that, you have combusted the known mass of the organic sample. Here, remember the mass of the sample we used was W what? Let me go back. So we use a known mass to be W grams, not any quantity at all. So W grams of that, and we burn it with excess oxygen, and the excess, it should be there because we want to convert all the mass into the gas, okay. So it's very important, all the mass into the gas. Now once you do that, you have converted. Now after conversion, you will get a certain quantity of carbon dioxide and also certain quantity of water. All you need to do is to go and find how much of the carbon dioxide is produced, and go and find how much of the water is produced. Once you find how much of the carbon dioxide is produced and how much of water is produced, you automatically can find how much of carbon dioxide and how much of carbon is in the produced carbon dioxide, and how much of hydrogen is in the produced water. So this is the trick. That is all. So just convert the carbon and hydrogen with an oxidizing agent with a known mass to some amount of carbon dioxide and water. And then when you do that, you will now go and then absorb. So here, carbon dioxide gas is in the system, water gas in the system. So go and absorb. So you use what you call a tube that has been previously weighed containing this. A tube that has been previously weighed containing this. So let me just draw a fake tube here. Okay. So let me use a color. So let me just draw a fake tube here. So this is maybe one tube, a U tube, okay. So you can just draw some tube here. Now inside this tube, okay, we have a compound that can absorb the carbon dioxide produced, and the compound is what? Sodium hydroxide. Sodium hydroxide. So the sodium hydroxide will be inside the tube. So this will be the tube, and this tube has been already weighed. So you know the mass of the weight already. So it has been weighed, okay. It has been weighed. So previously weighed test tube, okay. So this tube has been weighed. So we know the mass already. So once you know the mass already, and containing the carbon dioxide, you then pass the tube, okay, through the system of, that is through the reaction vessel, to absorb the carbon dioxide. So carbon dioxide, let me change the color, sorry. So carbon dioxide will be absorbed by this sodium hydroxide. So the absorbing agent for carbon dioxide is sodium hydroxide. So it will absorb it, and then once you absorb it, you then go and what? Re-weigh it, okay. Re-weigh the tube again, and once you re-weigh the tube, the new mass, okay, the new mass, you obtain the new mass, okay. You obtain the new what? Mass or new weight. So to find the mass of carbon dioxide, okay, that has been absorbed, you subtract the what? The new weight, okay, of the tube, the new weight or mass. If it is in weight or mass or whatever, you can do either mass or weight, okay. The new weight from the what? from the old one, okay, from the old old weight. So once you do that, you find the mass of the carbon dioxide. Very simple. So the mass of carbon dioxide, okay, that is produced have been absorbed by the sodium hydroxide. So that is there. So you find that. So let's say that the mass of carbon dioxide produced is y grams. Okay, so we have absorbed the carbon dioxide from the system. Okay, we have absorbed carbon dioxide from the system. Now, what else again? We have to go and absorb the water. Okay, the same procedure, we have to go and absorb the water. Now, you also use a tube, a previously weighed test tube. So let me change the color to green. Okay, so you pass a previously weighed test tube, a tube containing the something that can absorb the water, and that is magnesium oxochlorate. Okay, it is magnesium oxochlorate. Okay, so magnesium oxochlorate, this is a compound, okay, in a tube that can absorb the water, can absorb the amount of water produced. So you can absorb the amount of water produced. So once you have absorbed it, that means you pass the tube containing this one through the reaction, and the compound inside the tube will absorb the water produced. Now the mass of the water is found by subtracting, okay, the mass of the water is found by subtracting the old weight of the tube, okay, from the new weight of the from the tube. So that is the new weight, okay, the new weight. You take the old weight away from the new weight, okay, and then you get the mass. So let's assume that after doing simple subtraction, which everybody can do, we got something like S grams, okay, got something like S grams, okay. So let's say, let me change the color here to S grams. So here I'm going to get X grams. So here I have Y grams of carbon dioxide and S grams. Now I have the masses of the absorbed carbon dioxide. So what is next? Very simple. What is next? We are going to use this mass to find the amount of carbon and hydrogen within the carbon dioxide. Once we know the amount of carbon inside the carbon dioxide, we automatically know that that is the quantity inside the sample. And once we also know the mass of hydrogen within the water, we automatically know that that is the mass within the sample, because all the mass has been burned, all the sample has been burned into complete, that is, there's a complete combustion. All the sample has been converted to carbon dioxide and water, and so therefore that is what we are going to do. Okay, good. So let's begin the mathematics. So let's do our calculation. So very simple. That is, let me write here calculations. Okay, so let's do our calculation. Let's do our calculations. Okay, so here we are going to write all the information down. That is the mass of the sample that we bent. Remember we said that let the mass be what? We represent it by what? Do you remember that we said it should be, say, W what? Grams, right? We use W grams for the mass of the sample, and we, after our subtraction of mass of carbon dioxide, after doing our subtraction, what did we get? We said it should be what? Y. Should be Y, right? Good. We said it should be Y grams. Good. Should be Y grams. And then we said mass of water should be what? After our subtraction, we said it should be what? It said it should be what? S grams. So let's say S grams. Okay, so S grams. So these were the calculations that we did. Now we are now going to use it to find the mass of the mass. So let's find the mass of now carbon. From here we find the mass of what? The mass of carbon in CO2. Okay, good. Now how do we find that? Very, very simple. All you need to do is to know, okay, the molar mass of what? Carbon. The molar mass of carbon. Okay, the molar mass of carbon, and then the molecular mass for the compound. Okay, the molecular mass of the compound of the sample. Okay, oh no, the molecular mass, all you need to know is to know the molecular mass of the carbon dioxide. Very simple. Okay, you need to find the molecular mass of the carbon dioxide. So the molecular mass of the CO2. Have you gotten that? And then you multiply it times the what? Times the mass of carbon dioxide. Okay, times the mass of what? Of what? Carbon dioxide produced in the tube. Okay, times the mass of CO2. So this is what we do. Very, very simple mathematics. Now okay, so what is the molar mass? One carbon atom has a mass of what? 12. That is it, the mass of 12. Okay, one carbon atom has a mass of 12 grams, okay, per mole. And again, the whole molecular mass of the compound. Let's find it. Let's find the molecular mass, okay, for CO2. Okay, carbon is 12, one carbon is 12, and then there are two oxygen. Each oxygen carry a mass of 16, and so we are going to get what? 44 grams. So 44 grams per what? Per mole. So it means that the molar mass for carbon dioxide is what? 44 grams per mole. Okay, 44 grams per mole. Once you know that, and then you what? Multiply it times the what? Mass of carbon dioxide. So just find the mass of carbon dioxide produced. Mass of carbon dioxide. Okay, here should be 2. Okay, there 2. So mass of carbon dioxide. So this is the formula. This is the formula we use to find the mass of carbon in what? Carbon dioxide. That is very simple. Now once you know the mass of carbon within the carbon dioxide, we now move on to find the percentage of carbon in the sample. That is by small mathematics. That is percentage by mass of. So then you do what? Percentage of what? Carbon within the what? The sample. So in that case, we are going to talk about the mass that we got from the first one, the mass of carbon that we got from the first one, all over what? The mass of the whole sample. The mass of the whole sample. Okay, because this time we are comparing the carbon, okay, to the sample, not the carbon dioxide. Okay, then times 100, because we are looking for percentage, so this time 100. So basically that is the mathematics, and we have chose some variables, so you can choose to put them inside. But if you do them, this is also the same thing. Okay, you can do the same thing by organizing it very well, and you get your mark. So basically that is it. Now very simple. This is the masses that we got, and this is the formula. And mass of carbon, or that is carbon in the mass of carbon in CO2 is what? The molar mass of carbon over the total molar mass of what? Carbon dioxide times the mass that is produced in the tube times the mass that is produced in the tube. And this one too. So now we continue again. Mass of carbon dioxide is the molar mass of carbon over the total what? Molecular mass of carbon dioxide times the mass produced in the tube. So it's just like a fraction. That's the fraction of the mass produced. You just express the fraction. Just express the molecular masses, okay, of the atom to the to the carbon dioxide as fraction and multiply it times the one produced in the tube, and then you continue with the mathematics. The mass you get from here, divide it by what the mass of the sample, that is what W, and times it times 100. Now, and then you are good to go to find the percentage. Okay, you are good to go to find the percentage. You can do the same for water. So water too is the same. Okay, water too is the same. Okay, let me zoom in here. I'm going to do water, so let me zoom in here. Okay, so here water too is the same. So what do we do? Very, very simple. Okay, what we said earlier, we will do the same thing. So mass of what? We will do mass of, so that is, we'll do mass of, that is mass of what? Of hydrogen. How do you find the mass of hydrogen in water? The mass of hydrogen in water is the same here. Okay, alright, so the mass of water is the same that I've done already. So you just express the molar mass. Okay, that is the molar mass for water. Okay, the molar mass for water all over what? The molecular mass for the molar mass for the hydrogen all over the molecular mass for the what? For the water, all over the molecular mass of the water, and then you multiply it times the mass of the water produced in the tube. So m of water produced in the what? In the tube. Okay, so you do that, and then once you do that, you move on to find the percentage, okay, of hydrogen. So find the percentage of hydrogen. Very simple. The mass you obtain here, so the mass that you got from the first one divided by the whole sample, because percentage is struck by the sample, not by the carbon dioxide. So by the mass of the sample, and then because we are dealing with percentage, you multiply it times what? Times 100. Okay, multiply it times 100. Okay, so basically friends, that is what it is. Okay, basically friend, that is what it is. So very, very simple, very, very simple to understand. This is not anything difficult at all. This is how we determine the element. This is how we determine the various, okay, percentages. This is how we determine the various percentages inside. We will take some questions to support this in our next video, to be able to find the empirical formula and the molecular formula and the structural formula. We will take some questions to add it, and then you understand that. But this is what it is. Sometimes they can also just describe it raw like this, and that is what you are supposed to say. Thank you very much once again for following these lectures. Come, let's continue the empirical determination and the molecular mass determination. Thank you.
But the enemy won't worry me. I go show all of them tragedy.